first one, as we saw. So that will come out to be 18i minus 12. This is a complex number, okay? This is a complex number. This where this part, real part of this complex number is minus 12 and imaginary part is imaginary part is, can you hear me? Okay, I want you to tell me imaginary part. What is the imaginary part of this number? You can write it in this form. Suppose this is x plus iota y. This is your standard form of a complex number. This is the standard form. So x plus iota y, okay? So x is the real part and yes, iota y is your imaginary part.
Right.
So your imaginary part will be 18 iota. I'm writing it down for you. Okay. What if I say like I want to find the conjugate of a complex number? What do you understand by a conjugate of a complex number? Conjugate. Okay, what do you understand by conjugate of a complex number? I'm writing it on the whiteboard. Have you like just started with the complex number, or in your regular classes at school, have you just started with the complex number? No, we don't add -1. Like conjugate is a number, like when we multiply a complex number, I'll write it down and I'll speak also. When we multiply a complex number with its conjugate, okay, I skipped down that part, okay, sorry. When we multiply a complex number with its conjugate, we get a real number. We get a real number. So, what is it visible to you? What I am writing? See that again. Okay. When we multiply a complex number with its conjugate, we get a real number. That means we'll come back to problems. I just want to cover this topic. This will be like helpful during our problems. So that means x plus iota y. I'm writing the complex number in its standard form. X plus iota y multiplied by something, I don't know what is that something, will give you a real number. What do you understand by real number? Like the iota part will be removed. Okay, so it could be like, to make it simple, it will be a function of only x and y with all the real parts only. Suppose I'm saying
Understand? Understand?
okay, that is real part only. So I'll write the conjugate as, like we express it as x plus iota y with a bar over it, entire on the entire of it. Okay, so this is the conjugate. And this is equals to x minus iota y. So what happens actually, like when you multiply, like we know the conjugate, okay, that is x plus iota y with a bar over it, and the way we evaluate it, it comes out to be x minus iota y. So what happens when you multiply x plus iota y and its conjugate, that is x minus iota y, get only real part. Like we'll verify it. You want to check on it? It is lagging for the text. Okay, I didn't get that. Yeah, there might be some network connection errors or problems. So, is it visible to you clear? Or is it visible to you? Hello? Okay. So we'll multiply the complex number with its conjugate. X plus iota y multiplied by x minus iota y. Its conjugate, okay? That will give me, uh, can you can you speak what will be the result? X square. Yes, Derek. Okay, you're drawing. Distribute. Yes, correct. We'll do it as such. Okay, this is minus y. It didn't occur, or I don't know. X square, like we'll distribute x, will multiply x with x minus iota y. So that will give us x square minus iota xy plus iota yx, and this is again the trickier part. You'll get minus iota square, will evaluate it, and y square. Okay, is it clear? Okay, good. So we can cancel out on these terms, like these are similar and they are opposite in sign. So that gives us the remaining part as x square minus minus 1, like we know iota square is minus 1, y square. That comes out to be x square plus y square. Now as we can see, the final result on multiplying the complex number with its conjugate always eliminates the complex part or the imaginary part and gives us a real number. Okay, this is purely real number, x square plus y square. There's no imaginary part attached to it. So how do you find a conjugate of a complex number? You just put a bar over it and you substitute the plus sign between the real and imaginary parts with a negative sign, with a minus sign. Okay, okay. Is it clear? So we can move back to questions. Is I is I always negative? Yes. Like iota has a value of, like, you know how to, like, earlier when we were, like, you must have read in your earlier classes, like under root of minus 2 is not defined. But today, when you are in 10th standard, you are learning new concepts. Okay, so we have a value, a definition for under root of minus 2 as well. Previously, it was not defined to us, but now it is. We can write it as under root of 2 multiplied by under root of minus 1. So that is under root of 2 iota. I can substitute minus 1, negative 1 with an iota, just to make it like good, look good. Like we have an entire, like as we deal with the real part, real analysis, we have an entire topic syllabus for complex analysis as well. So you will learn much more in your higher classes. But for now, and also just to remember, like you saw iota square is minus 1. Okay. What is iota cube? Or say iota power 4. What is iota power 4? Minus 1 square, or you can just remember it as 1. So iota to the power 4 gives you 1. In the same context, can you tell me what is iota to the power 100? One, very good. Like, okay, we'll take iota to the power 4 over to the power 25. That will give us 1 to the power 25. That gives us 1. 1 to the power anything gives us 1. Okay, very good. And what is iota cube? Say. -1? Are you sure? One? No. I want you to try it on your own. See, we can write this as iota to the power 4 by iota to the power 1. Okay? This is same as iota to the power 3. So you know this value. This is 1. This is iota to the power 1 is iota I. So this comes out to be yes, please. This comes out to be I. No, I with a negative sign because it is the reciprocal of I. Okay, very good. Yes, reciprocal of I. Okay, so you're familiar with this part. Okay, let's move back to your questions. Okay, I'm making a new whiteboard for solving the problems. It will be convenient for us. Okay, so done with the first question. The question was actually the write the expression as a complex number in standard form. So as you said, we used the distributive property and multiplied 6 iota with 3 plus 2 iota in question number 22 and got the answer as 18 iota minus 12 or minus 12 plus 18 iota. You always write the real part first and then the imaginary part. In general, that is the standard notation. Okay, coming to question number 23. Iota. Yes, there. Are you there? Hello. I solve it. Yes, I want you to if you are facing any problem, we'll go through all problems up to 33. I want you to go for question number 23. It is iota bracket 4 minus 3 iota, right? It's not a difficult problem, similar to the problem you just solved. So, iota bracket 4 minus 3 iota. Please ask for, you can interrupt me anytime if you have any doubts, okay? Don't pile up your doubts or anything. If you have even a slight doubt, even a slight confusion, you can ask me again and again, okay? Please be.
How can I even see? What is this?
Can you see on whiteboard too? How do you use freehand with a mouse? Okay, I have a graphic tablet. Like I have a graphic tablet, so I'm using a graphic tablet. It is convenient. It is very much convenient, much better than a mouse. Okay, it is difficult for you to. Okay, I understand it. Okay, okay. So you can create a text box. Like you click on the text box and you select the text box and you click. Okay, yes, good. Yes, you were doing it right. Is it 8i? No. You were writing it correct. What happened? No, why? Okay, in the problem. When it is actually not clear to me if it is, yeah, it might be possible. Like, I'm really sorry. Like, it is not still not very much clear to me. So, okay, it might be 8i. Yeah, but it doesn't matter. Like, you can solve with 3i also. It's just a problem. Like, if you can't do it with 3i, you can do it with 8i as well. So, let's go with the 3i only. No worries. 4i, yes. Like you can write iota square equal to -1 directly. Like for such problems, you need only one step to get the final, to write down the final answer. It is pretty much clear from the from the question only that it comes out to be 4 iota plus 3, because -3 into -1 comes out to be +3. So 4 iota plus 3. Yes? 3 square. Very good. No, but you have already, like there will be a minus sign when you are opening the bracket. Yes. Minus where? Okay. It will be like when you open the bracket, it will be 4 iota. Okay. 4 iota minus 3 iota square. So that when you put the value of iota square, that is -1, then you'll get 4 iota plus 3. Or you can write it as 3 plus 4 iota, because you always write the like real part first and then the imaginary part. This is your answer. Is it clear? Like we have just used the distributive property. Look at this part here. We'll multiply I with 4 and then with 3i. So 4i minus 3i squared, iota squared. Okay, let's solve it for yes, as you'll go through problems, it will get much easier for you as well. Let's solve it for another question. Question number 24. Okay, we are doing 23, right? Right, 23. And now 24, moving on to 24. Okay, I didn't check your message actually. Sorry. So, okay, question number 24 is 5. Is it plus or minus? I cannot see. 5 plus 7 iota multiplied by minus 4 minus 3 iota, right? Okay. Minus 4 minus 3 iota. Okay. Okay, thank you. Yes, coming on to whiteboard. Again, we'll use the same. Like this is as simple as you know how to multiply a plus b. Okay, you don't have to worry about the iota part. Okay, you know how to multiply this. A plus b multiplied by c plus d. Okay, so this is equally as easy as, like, we'll distribute this to this, and secondly we'll do it for b. Can substitute the value of FOIL. What is FOIL? Okay, you're solving it. Okay, good. 20, right? Plus 15 iota, correct. Iota square, yes. Okay, nice. Good. Okay, I'll write it down for you further. Like, it is actually difficult to write without a pen and tablet, yes. So, okay, this comes out to be like the real part, that is 20, and when you will multiply 21 with iota square, that is -1, that comes out to be 21, correct? So 20 plus 21 plus, I'm writing it in the standard form, x plus iota y, x plus iota y. Always try to present your answer in the standard form only, or you can use negative sign here. I'm just avoiding it for now. Okay, so iota, that comes out to be 28 minus 15, that is minus 13. Okay, so this is your answer. I am looking that we have slightly changed the question, like it was plus 5 minus 7 iota. Okay, you have more practice problems for you as well. This is like 41 minus 13 iota. Just writing it. Where did I get minus 13? Okay, uh, look here, 28 and 15. Both have both are with the iota, like they have the iota term. Okay, so I took the iota common, and minus 28 plus 15. I can write it down as minus 28 iota plus 15 iota, which gives me iota minus 28 plus 15. That gives me minus 13 iota. Simple. Yes. You still have a doubt? Shall we move on to next question, or like,
Okay.
is it clear? Okay. Okay, next question is again the same. Like you have two complex numbers, a and b. You have to multiply a and b and get a complex number as an output. Okay, minus 2 plus, I think, okay, let's do it. Minus 2 plus 5 iota, right? Okay, minus 2 plus 5 iota. It is minus 1 plus 4 iota. Yes. Let's try to do this question in 15 seconds to the max. You have 15 seconds. Uh, Hello. Yes, Derek. Okay, you're doing it. Good. Okay, that gives you. Okay, I'll write it down for you. Very good. Can I write like directly minus 18 minus 13 iota? Can I write this? Like this is your minus 20. When you put the value of iota square, this is minus 20. So minus 20 plus 2 gives you minus 18. And minus 8 iota plus minus 5 iota gives you minus 13. So the more you practice, the more easy it looks. Your calculation will also be much faster. Okay, clear? Is this clear? We have an interesting question on next. The question is minus 1 minus 5 iota multiplied by minus 1 plus 5 iota. Okay. Can you do 28 instead? Okay, yeah, sure. After that, after this, like we are moving on to 28. Like this has an interesting property. I want to. This is a number. Suppose, say, complex number z, and this is z conjugate. Can you see? Like this is your x, this is your y, or I can say, like, suppose, say, let's say y only. This is again your x, in reference to that y, this is your minus y or iota y. Let's write down proper notations. So this is a complex number. So what you can do, like, the output of a complex number. When you multiply the complex number with its conjugate, that gives only the real part, square of real parts. We just looked at. That will give you -1, because your x is square, and it doesn't matter because it's a square, you can use plus and minus for that. And as your y is concerned, it is -5 square. That gives you 26. Okay, so always remember the advantage of knowing the conjugates. Like, if you can identify the conjugates, this is a basic problem, but in further classes also, you'll see the properties of conjugates. So always try to remember this. Okay, and question number 28 now. Is this question clear? Yes. Okay, good. Very good. Question number 28 is 7 iota divided by 8 plus iota. Okay. No, that is not good color. Let's use black. 7 iota. This problem will be the last one, and then I have to go. Okay, okay. After this problem, we'll go through one more problem, question number 33, say, or 32, and then you can leave. Okay. I just want to we should finish up with this topic. So in next class we can start a new fresh one. So how? Okay, very good. Thank you. So how will you do it? Any idea? Like I just told you, you have to make the denominator part real number, because it is very difficult to solve with an imaginary part, like the complex part in denominator. So yes. Okay. Yeah, yeah. Denominator. Get it. Okay. Since multiplying a complex number z dot z bar with its conjugate will give you a real part. Okay. So that should be our purpose. We want to eliminate the imaginary part from the denominator. So we'll simplify it as this is your 8 plus iota. Okay. We'll multiply and divide it by multiply and divide it by 8 minus iota. Because I know like the conjugate of this part is this. Okay. So I know that when I'll multiply the conjugate with the complex number with its conjugate, I'll get the real part. And this is also 8 minus iota. Okay. So solving further, that gives us 7 iota. Like I'm writing step by step, so it is much clear to you. 8 minus iota divided by what I can write. Like it is any guess? Can I write like just suppose I want to save some time. So can I write 65? You know 8 square is 64 plus 1 square. Only the real parts. Okay. So that gives me somewhat like 56 iota I'm writing it straight plus 7. Why is 65? If you want to simplify it further, this is your iota by 65. Okay. Like whenever you have such terms with numerator over denominator and you have a complex number, like you have a complex number with an imaginary part in denominator, so you'll always try to eliminate the complex thing from denominator. In numerator it's fine, you can evaluate, but you'll always try to eliminate complex number from the denominator. And how you will do it? By multiplying and dividing by the conjugate of the denominator complex number. Okay, like see for okay, yeah, and like see for example, in next question it is 6, question number 29, it is 6 iota divided by 3 minus iota. So I want to eliminate the denominator part, like it is not looking good as well, and it is not easy to evaluate, easy to solve further. So I just want to eliminate the complex part from denominator. So I'll multiply and divide it with 3 plus iota. Okay, that will give like in numerator any complex part is fine, but not in denominator. Like suppose in all other questions also, like in question number 33 as well, you have 1 minus 6 iota divided by 5 plus 9 iota. If I'm like speaking it correct, I cannot see it clearly, but it is somewhat like 1 minus 6 iota divided by 5 plus 9 iota. So you'll eliminate the complex part from denominator, you'll multiply and divide it with 5 minus 9 iota, the conjugate of denominator. Okay, so let's write it down, the last question only. After that, if you wish, you can Okay. See the question once again. 1 minus 6 iota. And I hope like you'll be able to manage on other problems. Yes? Because like you have only mm, 3 to 4 variations throughout the this like topic. So it is not much difficult. If you know how to solve one problem, you can go on for 4 as well. Yes, I want you to solve it. If possible for you, you can like do it in your copy notebook. You don't have to type it, and you just type the final answer. You can solve it down on your notebook. Are you like doing it? Okay. I don't know. Like we just learned how to solve it. Like you see, the first step, you will proceed with in steps. Look at the denominator part. Look at this part. This is complex. I don't want complex parts in denominator. So I'll try to eliminate this. Okay. Step 1. Let's write it down. Okay. And step 2 is your answer. Like there's only one step you have to perform as such. So this is as simple as we did a previous problem in the previous problem. 6 iota. This is 5 plus 9 iota multiplied with 5 minus 9 iota. Do you understand how to like find the conjugate of the complex number? You just have to substitute this positive sign with a negative sign. If a complex number is z, we represent its conjugate by z bar. And when we remove the bar, we substitute the positive sign with the negative sign. So this is 5 minus 9 iota again. We can't do this. Okay, this quantity in itself is equal to 1. So we are multiplying and dividing with the same term. So we can't do this. It is just a trick to remove the complex part from denominator. Okay, so further we get it is 1 minus 6 iota, and this is multiplied by 5 minus 9 iota. In denominator I can write very simply. I know it is 25 plus 81. Okay, so, and in numerator I will write 5 minus 9 iota minus 30 iota, and minus, because minus minus is plus, so I'm already using the value of I squared, so I'll write 54. Okay, like this, minus 6 iota into minus 9 iota will give me 54 iota square. So I have used the value of iota square, and that is my minus 1. So that's why there's a minus sign here. Okay, so this comes out to be minus 49, and denominator it is, yes, 106, and this is minus iota 39 by 106. It's simple, as simple as that. Like we have added the iota terms and the real terms. You cannot add like these terms. Okay, this is wrong. If you are thinking like adding 5 and 9 iota, no, this is correct, and we add only real to real and imaginary to imaginary. Always remember. And also, like we have the answer now. So okay, you have to do other homework. Okay, so are you done? Are you thorough with what we have studied so far? Okay, thanks. I'll review it again when I get the chance. Okay, sure. Yeah, and review it and solve the problems. Definitely. That will help you keep a hold on your concepts. Solving and practicing is the most essential part in mathematics. Always remember. Okay. Yeah. Have a good day. And take care. I'll see you soon. And do complete your work, like this homework, question number 22 to 33. Okay. Okay. Very good. Okay. I'll see you, Derek, then shortly. Bye bye.